G'day guys. On some of these videos on the older detectors that, these ones I haven't really examined the components for years. And I just realized I said some parts were something and they weren't. And I think I called 4053s, 4060s or something. I don't know where that come from. Yeah, I think I haven't had enough sleep, and that's probably true. A couple of nights I woke up very early, and yeah, about 5 hours sleep 2 nights running, and I don't run on that. I'm an 8 hours sleep person. I don't want 5 hours sleep. So what I thought I would do, I'll give you all the part numbers for the GP Extreme 3000, 3500, basically all the same. So if you've got smoke coming out your ICs, I'm going to tell you what they are. This is 100% correct. I have measured these chips. I have all the data written down. So we'll just go on this board here and we'll go left to right. So the first chip here, and that is an LMC 660. Okay, this does all your audio work, and you can change some of these resistors here. I'm pretty sure that you can do that. I just want to make sure that I'm on the ball. Where's the audio wire? I've got to follow the audio wires. Yeah, I am correct. And there's a couple of mixing transistors there. I think they're the mixing transistors. But yeah, okay, first chip, LMC 660. Let's go across the board here. We have, these are all 74HC chips, by the way, 74 series. And that is a 4316, that chip there. Now, I've seen everyone guessing what these are, and they've all got the wrong part numbers on them, and I usually just don't say anything. But it's about time, that we put the right part numbers on these. And I've seen people write their LT1056 chips. That is wrong. They are not LT1056. These are LT1050. These are chopper amplifiers. Okay, 4 of them across there. Okay, let's go and flip the board, or we can go to the main board if you want, because it's sitting there already. We'll go on the main board. Okay. Now, this is 100% correct. These chip numbers. These are tested, back tested over a few years. There's a lot of chips here. Your oscillator stage is here. This sets up your waveforms for your transmit receive, and basically is related to this eeprom here with your timings in here. First chip, we'll start at the top and work our way down. First chip here, 4040. Okay, and that's just a eeprom 27 something. I haven't got that written down, but they're common. They're one-time programmable things, or you can get the window version. And yeah, I really can't remember what they are off the top of my head. I've never had to do anything with them. I've popped one out once and played around with it with a programmer, and I only did that for a couple of days years and years ago. So not really, that's not going to play up anyway, that thing. It's going to keep working. Okay, the one everyone has trouble with, these ones in here. Okay, next to the resistors down in here. Hopefully you can see them. They're just so I'll bring this forward a bit, or actually I'll tilt it up. So bear with me. while I try and do this. Okay, move these wires. Okay, here, these ones here. 1, 2, 3, 4. Now, a lot of people get those wrong. They are TLE 2072 is the correct part number for that, and that. Back tested, proven. That is what they are. Okay, we've got directly under the so we'll go directly under the toroid here. There's a chip here. That is a 74HC04. That's what that one there is. This one here, why haven't I got it written on my sheet? So the next one across is that one there. Oh my God, what is it? Hang on a second. I'll have it written down. I don't know why I didn't copy it across, but hang on a sec. Okay. Okay. I know what it is. I know what it is. I know why I didn't write it down. Okay. That one there, 74HC 4538. Is that one there? Okay. These two here, big fat ones, they are 74HC 273s. That one and that one. Okay, we'll keep going across. And these are the ones I called them 40. I can't remember what I called them, 4060s or something. I don't know. I must have, yeah, eaten the wrong mushrooms or something when I said that. That's a ridiculous thing to say. These are all 4053s. 4053s. Okay, 74HC 4053. Those ones there. We'll go right over the other side of the board and get rid of some of these wires here. But in here's a little obscure one. No one ever gets this one right either. That is a TLE 2022C. Just an op amp. I think it's an Excalibur series op amps, the 2022, but I'm thinking a long time ago. I'm pretty sure it is though. Make sure I'm in the right area. Yep. That is the one. Okay, the one next to it. They think people think these three here are the same. They are not. This is a TLE 372C. This one. The next one along is a TLE 2022C. So you got 2022, 372, 2022. Okay, so that's those. I don't want to go down to. I'll just do one more on this side of the board for you, if you can see it. Where is it? It's down here. God, it's funny, you know. I'm so used to looking at the GPX boards, and this one's down here somewhere. But this is the correct one. It's a 372. So you got a 372 there and a 372 there. TLE 372. Now we'll go across. We'll go up the board, back on the other side of it here. These ones. These 16. I think they're 16. So they're under white paint. It's very hard to tell, isn't it? Okay. That is a 4538. This one here. 4538. Yeah, 74HC. They're all the same. 7411D is this one here. 7411. Okay. This little one in here. A lot of people get this one totally confused and bamboozled and put all sorts of weird stuff in here. That's just my battery telling me it's, or battery charger telling me it's finished doing a cycle, recharging my electric drill, I think. Or, yep, no, it has. It's finished cycle. Just letting me know. This one here, it's a 2142. 2142. And for the life of me, I can't remember if its prefix is TLC or TLE. I have to look that up. But you won't have, it'll either be a TLE or TLC. There's not a TLE and a TLC one. Whatever it is, it's one or the other. And the critical one, if you go into mouse or DigiKey, put in the search bar 2142, it'll come up with the right device. It's in the op amp families anyway. So down we go. And I think did I mention these? Probably not. Okay, that's TLE 372, TLE 372. Here, just op amps. Okay, we'll go right across here. This is a 4053. Another one confuses everybody. They never work it out here. It's this little tiny one sitting in here. That is a 2072. It'll be a TLE 2072. And our favourite thing that wants to blow up all the time on these detectors, and whatever reasons, because they've got so many outputs and anything goes wrong, it takes the damn things out. That is the old ADG333, right? That's what that is. And what was here was a NE5534, and NE5534. You really want to put AD797s in these positions here. So that's that. Now I'm going to flip the boards over. Oh dear me, this is interesting, isn't it? Okay. Now, I thought these were, what did I call them? FL214s or something that were originally there. No, they weren't. See, I just haven't done this for so damn long on these detectors. Like I said, these were BSP121, right? And so is that damping one there as well, BSP121. And you can leave that there, it's no big deal on the damping, but I changed these to the 2SK1334s, which are a far better transistor, or MOSFET. Well, it's got 3 legs, it's bloody transistor to me, but it is a MOSFET, N-channel MOSFET. Okay, so you want to know the chips. That's the important bit. That's where we're up to here. Okay, most of this stuff's pretty pedestrian. Okay, that's a this is the high voltage regulator part of the circuit. There's a whole stack of transistors, diodes, xenodiode there. Now that is a 4093, by the way. So a 4093 just sits in there, and that drives the FET, the one that's acting in its resistive region that regulates that high voltage. Okay, that diode there, that's your negative output for negative 15 volts out this side, and this one here is your 5 volts negative. Remember, all this stuff's negative. It's like positive to ground. It's like a pommy car, okay, an old pommy car. So remember, the regulated outputs are all negatives, and that basically goes off and drives the MOSFETs, which is over here. There, you know, where they're sold in on the other side of the board. Okay, that FET there, that's a 455. That drives your switch mode power supply. So if you've got no power rails anywhere, usually that thing cooks. This chip here, This is a 74. I called this something else once too. It's stupid me. It's actually a 74 HC240, and all it is a buffer. Like every second leg's tied together, and this drives that. Believe it or not. How to overcome the gate capacitance? Well, we just tie all these together and use it as a big buffer, a big driver chip for this. So, yeah, fantastic, isn't it? How that's done. I suppose these were dirt cheap, and they said, "Oh, yeah, if we parallel all the inputs up, parallel all the outputs, we can overcome the gate capacitance to this and make sure it switches hard and fast, hard on, hard off." Okay, I was saying here, these are the devices that are used to clean up the power rails for the very sensitive parts of the detector on the -5 and +5 volts. These are just SOIC MOSFETs. One's a P, one's an N. And this one is a 9410. It might be an IRF 9410, but I've just got it written down as 9410 and 9435. It might be IRF as well. For memory, like I say, it's a long time ago since I had to nut all this stuff out when I was working on these detectors. But, you know, now I've gone over it all, bloody will never forget it, will I? It'll be ingrained in the memory. These are just isolating and series rectifier diodes. The 5 and 15, there's 2 diodes this side of the board, 2 diodes the other side. The middle parts of these are not connected on this side of the board to the other side of the board. This goes to the output of the core driver MOSFETs, and it actually isolates them, and they basically join up again. Here, this is connected both, and this is connected on both, but it isolates the 2 FETs from each other through a diode drop, and drives your -5 and -15 out through an inductor here, which is just to clean off the square waves a little bit, so it doesn't fall foul of EMI compliance, and goes out and drives the coil. So these can fail. I've had these fail, and actually what happens is the detector goes completely noisy, very, very noisy, and you know what's going on there. And if these start breaking down, they go noisy because the 200 volts, which is stored in the capacitor on the other side of the board, starts back leaking, getting into the FETs, and it just leaks across through the internal diode biasing of the FETs, and ends up just 200 volts leaking into the circuitry. It just causes noise. So yeah, I've gone that. This is your filters down here. Your integrators, filters, so forth. There's more filtering in here, but I'll just flip it over again to get the other chips done. Now hang on, I've got to do this board, don't I? I've got to do it with where the micro lives. So I've got to turn this around and flip him down. So bear with me. I hope this helps you guys. Any of you fellas doing repairs on these, because it's horrible trying to repair something if you can't get a schematic, and 10 times worse if all the part numbers have been ground off and you've got no idea what they are. So we'll try and overcome that. These are so damn old now. I don't think Minelab I don't think Minelab even repairs these anymore. I think they classified as past the use by date. You'll have to check up with Minelab on that, but I'm pretty sure they refuse. I've been told this. You might have to check yourself, but I've been told anything GP3000 and older, they basically won't touch. That is my belief. That's what some of my customers have told me. It might be wrong. I don't want to say that's the a fact, and then Minelab go, "Oh, you said this," and try and kick my proverbial over it. But anyway, So we're on this board here. I actually should have flipped it around the other way, but no, we can work in reverse because that means I just got to read my notes backwards and upside down. Let's go here. First chip. Oops, hang on. You can't see the first chip. Helps if you can see the first chip I'm going to talk about. Okay, I can read upside down, so that's all right. On a lot of these detectors, there is a chip here. This one hasn't got it. It was basically a UART for communication into this. Some have it, some don't. And I think the early GP Extremes, notice the terminology and the wording I use. I think, I'm not 100% sure. But for some reason, they may not have had the communications worked out, or a shortage of chips, or whatever. They just weren't installed. Okay, and that's a Max 242. You can look that up, made by Maxim, of course, which has recently been bought out by Analog Devices. Okay, so that's where the UART was. Next one, 74 HC 132. That one there. Okay, this one here is a little eeprom. Okay, it's a 93C 46. So this works in relation with this here, and this chip here, a lot of the early Minelabs all used the Hitachi or Renesas, what it's called now, chipsets, and that's the H8, and that's a 3048. So it's got code in it. It'll have fuse protection, and when they program these, they usually I haven't checked actually, but usually blow the fuses so you can't read the data back out of the chip. I don't know. I never checked it. Never had to. Right. I just want to see if I'm getting particular inputs and outputs working. I usually work out if it's behaving itself off the ADC here, off the ADC um, output lines and so forth. If the ADC is running and all the waveforms usually correct, this is usually okay. That is what I've found. I've never ever found one of these that's dead. Never, ever in my life. But I have found them on the GPXs, the bigger ones. But that's another story. We're going for the chips here. Okay. Next one. This one here. Okay. That is a TLO. Hang on. I better turn this around and make sure I'm reading it right. Yeah, TL061C. This one here. Okay. The next one is the ADC. That's an MX7541. Okay. Do I jump? I'll jump right across the other side of the board to here. This one here. The TL064, which is just a quad op amp. I shouldn't shorten it to op. You don't know what I'm talking about, but yeah, it's just a four banger op amp. Dirt cheap thing. You can put anything in there. There's a lot of replacements out there. I mean, they'd put anything in there. Okay, next one down the line here. Is that little one there? These are the others that people got no idea what they are, and they guesstimate what these things are. Okay, so that is a down one there. Oh, sorry, I stuffed up. See, I shouldn't be Hang on a sec. I shouldn't read this. It's getting too confusing. I've already told you one wrong part number. I'll spin it round. Do it properly, because if I'm reading upside down, because I get the lines of chips like here to here muddled up, that is a problem. Okay, so I'll do that, and I'll zoom in a bit. Hopefully it doesn't crack the wobblies. Okay, that's it. There we go. So I'll start off where I was correct. I said I can read upside down, but I actually got the placement in the wrong spot. So we'll go along here again. This is where I stuffed up this one. Okay. What did I say it was? A TLO61C? No, it's not. That's a TLO61C down there. Okay, this one here, 74HC14. Okay, 74HC14. And I got this one correct because I won't muddle that up. I know that off the top of my head, which is the MX7541. Okay. The TL064 is correct, is that one there. I'll do it right now so I won't stuff up. I've got everything out the right way. TL061C is that little one there. Okay. And another one, no one gets right either. This one here. You've got no idea what this is. It's a TLE277C. Okay. So anything of these that you have black smoke come out of or looks crispied or whatever, you can replace it. There is another one here, and make sure TLE277C. I just want to make sure on this because I haven't got this one written in for some reason. I damn well missed it. So I'll go and do it now because it'll keep it in line with what I'm doing. But the previous one is correct. I'll just go check up. You just hang on a sec while I do this. Like I say, I don't usually go through and replace every chip on these. So okay. Okay, TLE277C, that is correct. I just want to make sure on this. I've got it written down as LM311. I want to make sure that is absolutely correct. I don't want to say it's something when it's not. And to find that, I've got to go right into where am I? Where are they? Recents, that's it there. It'll be in here. I'll just find it. Okay, right there near those red caps. Okay. Wrong red caps. Hold on a second. No, that is why it wasn't written in there, because it is wrong. It's not a 311. See, it's definitely not. They're old notes that I got off someone else. Okay, this is the real notes. That's why it wasn't written in. Okay, it's a linear technologies device, right? And the actual, I've never replaced it. The actual number, it says this on it, right? LT 026, right? Which I don't think is the actual number. I think it's underneath. It's 1011. I have to actually look that up. First of all, I want to write that down. Bear with me. I'm on the computer at the moment, so I just want to write that down. LT 026 1011, and I'll just actually go and key it in on somewhere like DigiKey, which is DigiKey or mouse, so it doesn't make much difference. Their internal search on this stuff is really, really good. So we'll just have a look and see what the hell it is. LT, I'll put in 026 to see if it comes up. Okay. No, it doesn't. So it must be the other number. We'll just see. 1011. Yep, there it is. LT1011. I'll quickly. I've got a rough idea of the pin out, so I'll just check it, make sure what it is. Yeah, it's a comparator, 100%. That's what it is. LT1011. And the full part number is LT1011 IS8TRPBF. Not that you need all that, but it's just a comparator. Freaking expensive thing too, for what it is. Yeah, once say they're $5 each. Okay. It's probably something you get off Alibaba for 50 cents, but I don't know. So now we know what that is. I left my pokey stick over on the computer. So we're back again. Okay. So 100% correct on the part number of this one here. See, everyone's been running around saying some LM311, and what's a bloody LM311? It's not going to work in there. It is definitely that one there. Is the LT026, and the real part number is, well, that's written on the chip, by the way, 026, but the real part number is 1011. You'll never know the part numbers because these are all ground off under the white paint. So if you take the white paint off, there's no part numbers on any of these chips. So for repair work, it's an absolute pain in the proverbial, right? Okay, let's go to the other side of the board now because there's no more there. I'm just looking. The next line is down here and here, but we'll start here. Okay, that chip there is 74HC4013. So it's a 4013. This one here is a very pedestrian chip. This it's a 555. So one of the it's probably a CMOS version, but it's just a 555. Nothing special. What is it? I know they're like different designations, 555, but everyone made them. So it would be, if it's a CMOS version, it's going to be like a 3-letter prefix, like for CMOS, because that's how they tell the difference. But anyway, you could probably put a standard bipolar 555 in here and it'll work perfectly. I don't think it's fussy. I have replaced these before, and I think I might have put a bipolar in there, and the damn thing worked. So not fussy, but it's meant to be a CMOS one, but who cares? Enough drive and grunt on the board for it to work. And it's just a damn oscillator, That's your threshold, by the way. It makes your threshold, your noise. Where else are we here? I've got to get down here. I've done that one, and we've done that one. We go down here. There's a chip here, and the chip there. The one. Oh, did I miss that? Sorry, I did too. Ooh. Oh, that's another 372, by the way, guys. 372. Same as what's on the other board. I think there's what? 2 on there. No, 3 on there. So that's another TLE 372. We get down into the nitty gritty chips here, all your signal processing and so forth. Where are we? 4051. This one. 74HC 4051. And this one here is, well, there it is. It's a 4053. 74HC 4053. Pretty pedestrian type of stuff. I mean, cakewalk, walk in the park. Okay, so we did this one here. It's a 4013, the 555, and we got one down here. This is another one. No one knows what this is. And they'll scratch their head trying to work out what it is. No idea. What is it? It's a TLE 2021. That's what that is. TLE 2021. That's the chipset for this detector. So I don't think I've missed anything out. I've done, I'm pretty sure I've done all 4. Okay, so done that, and over we go. And I did that. So there it is. That is the chipset for the Extreme, the 3000, and a 3500. There's nothing really else. I suppose I can tell you some stuff here. This here, we call this the on-off switch saver. Okay, rather than switching the when you turn the thing on, battery voltage straight into the capacitors, and that instantaneous hard inrush current. If you did that through the normal little C and K switch here, in a very short amount of time, it would blast the contacts and start arcing and burn the contacts, and your detector won't turn on. So there's a little circuit down here. It's a little sensing circuit actually, and that's also, I think, for memory, we've got over voltage protection in here as well. If you put more than 7.8 volts in it, the thing just will not turn on. So what happens, you utilize the on-off switch here, and the switch just operates a little sensing circuit, and it turns this MOSFET on. That isn't, I think that's a 455 for memory. You can shove anything in there, it's not important. You know, what's a detector draw? About 800 milliamps, so put a 3 amp one in there, you know. I've had these things smoke up. I don't know why. I can't remember what, I think it might be an IRFL 455. I'm not 100% sure. I'd have to check. But in here, you can stick the biggest available amperage MOSFET in here, just so that you know, if it doesn't like getting switched and operating momentarily in its linear region and gets hot and then burns. Because what I've had, I'll tell you what happens, right? A lot of detectors have come in and this has failed, or they put the battery on backwards and they've the fuse, there's no fuse in the line, it hasn't taken the fuse out, and this diode here, which is, I think it's um, a, a back-to-back Zener, or it could be a normal diode and a Zener into one package. It's a Zener diode reverse polarity protection device, right? Like I say, it's covered in white paint. I've never scraped it off to find out, but you know, it's basically, don't stick your battery on backwards, or else we're going to smoke your battery or smoke these wires out or whatever. And what actually happens, I'm pretty sure it's the MOSFET that dies. So, you know, in this situation, I'd stick a 10 amp MOSFET in there, you know, and as long as it's got fairly low on resistance, you know, just a couple of, well, you know, whatever, I don't know, 50 milliohm, who cares? It's no great deal. The lower the resistance, that, you know, the less power dissipation, and 800 milliamps, it's not really going to dissipate much, is it? So you put a 10 amp device in there. You get 10 amp devices in that package, and you know, it would never blow up. But what I have found is I've had detectors come in, and all around this whole area here is completely charcoal, all around here, and someone's turned the detector on. Something's happened, and they've left the detector on, and this get all these burnt semiconductors. They glow red hot, like red hot embers, and sits there and burns the whole board. So there's been a couple of detectors that have been unrepairable because someone left the damn thing on, and it just cooked it all. So it's sealed, remember, smoke won't come out, you won't know, just leave it on and cook your detector. If your detector does not work and does not turn on for any reason, first rule of thumb, disconnect the battery, just in case. You know, you don't want to have you know, your super expensive newer type detector and it's getting cooked on the internal part and you don't know. So that's important. Uh, yeah, the rest of it, you know, it's just got resistors and capacitors everywhere. I'm not going to go over all that. That'll just drive everybody insane. There's those two diodes there. I was saying on the other side of the board, like this one here, I think is connected to the center on the other. This one here is connected to the center here. They are not connected to each other. These diodes are not connected to the other diodes in the middle of the two diodes. So it's only connected to the output of the MOSFETs, and this is joined with the other two here on this side and here on the output side. They're joined top to bottom, top to bottom, and not top to bottom, just the output of the FETs. Yeah, so yeah. Now I've probably said everything I need to say. I'm not going to go and waffle on. So I've got it all correct. Anything else that blows up on these, for memory, when the power supply here, sometimes it won't stabilize this 185 volt power supply. It just goes all over the place. The 4093 on the other side of the board can go funny, and there's a couple of transistors around at 4093 can go leaky. And just check the, I think someone asked before about the Zener, or Zener. Some people call them Zenas, or Zener. We'll call it a voltage stabilized diode. I don't know, Zener. The voltage across it when these detectors work incorrect, and I better show it just because I mentioned it. Someone did ask about it, so I'm going to point it out. There's a Zener diode under the 4093, and it's that one there. Exactly 12.2 volts is measured across this diode. And when it goes crazy and it won't regulate properly, check this, and God, this is really stretching the imagination. FMMT 715 or 716, and there's a whole heap of BC type transistors here, there, a couple of diodes, resistors, yeah. Yeah, when you work on this bit, remember it's floating. It's 185 volts on it, and if that MOSFET here goes open circuit, you can have up to 200 and something volts there. Don't touch it; it's gonna hurt like hell. If you grab part of the board, like where it's grounded or something, this wire here comes off the core. That's another thing you can do too. See this ground? This grounds with a screw into the case, and it connects directly on to the negative here. I don't know if you can see that. I'm trying to move it over. Cut that wire and put a 1K resistor in series. It isolates the electronics from the case, and you'll get a lot less strange coupling and capacitive effects. Cut the wire, put a 1K in series, and then put a bit of heat shrink over it. I've done that on most of the detectors I've done over the years, and I've done it on my own detectors. I've still got 3500s, I've still got extremes, I've still got 3000s, and they do come in handy from time to time. There's nothing wrong with these as a detector, as long as they're nice and the caps aren't dried out. You got the new semiconductors in there. You make it nice, fast, behave itself. Check all the wiring. What's wrong with these? There's nothing wrong with them. They work beautifully, Anyway, that's that. I think I've said enough about this. These diodes too, I said that's the 5 volt and that's the 15. They are low voltage drop Schottky rectifiers, by the way. Don't put, if they ever play up, don't put normal conventional diodes in there. Don't put any of the old standard rectifier type diodes. They're too slow, they'll overheat, efficiency will go down, and you'll probably end up with smoke. Make sure they're ultra fasts, or what's the other one? There's ultra fast, and there's another one that's got a sorry, I'm thinking of the recovery characteristics. Some are fast recovery, then you got ultra fast recovery, and you got ultra fast with a soft recovery. On power supplies, always use ultra fast, because it's a fast power supply. It's clocking pretty quick. It's not 50 hertz, I'll tell you that. It's look, I don't know what it is. I never measured the frequency anyway. But yeah, these should have a soft recovery characteristic to the diodes. It'll be in the specifications anyway for these. Soft recovery. That means that it doesn't snap off on and off hard and generate heaps of noise, right? So it's like it gives a gentle slope on the in and the out, mainly the out when you turn them off, because if you turn them off really quick and they snap off quick, they can generate all sorts of harmonics and ringing on the circuit. Depends how much capacitance is on the other end of it and so forth. I don't want to get into the technical side of bloody power supplies, so it's, yeah, just trust me. Soft recovery, and you don't want these diodes here, these ones either side. You don't want soft recovery for those. They are just ultra fast rectifiers. Basically, that's why you got your choke here. This choke that takes off any of the edge in, like the rise and fall time of square waves into the coil. It just slightly slows it down, rounds them off a little bit. We've tried this by removing it and shorting it out and putting it back. Makes no damn difference. Leave it there. It's an EMC compliance device, and also it isolates fast transient signals from receive, going back and getting squashed out, leaking into the rest of the circuit. This is made for a slow transmit on pulses, not fast decays. And because of the amount of inductance in it, I'm not sure what it is. It won't be much inductance, but it's probably enough to stop some signal leakage going back. That's my opinion. But that's that. I hope that is of some interest, rather than me trying to pick numbers out of the air on components and getting it, ass up half the time. I thought I'd go to the notes, draw it all out, go back through my back testing information, where I've actually got the oscilloscope out and measured pin by pin by pin and worked out what these chips are doing. And that's exactly what they are, because what I did then is I took removed the IC after I thought what it was. I put a known one in there, and if it continued functioning perfectly, that's what it was. So that was the hard and fast, and hard and fast, a very time-consuming way of working out the components. So yeah, okay, that's enough on that. Should I do a GPX and tell you what all the parts are on that? Comments, please. Catches.